Okay, welcome back, class. So we're continuing on in section 4.6 with problem 2 regarding solving exponential equations. So as I stated, the problems on this page will just be like slightly more in depth, but I know you can do it. Okay, so look at part E. As you can see, we have 2 to the power x plus 1 equals 5 to the power 1 minus 2x, and we have to try to solve for x. So before you do anything, just stop and look and think what you should do, and you may be troubled because this problem has x in 2 different places. It's up in an exponent 2, and it's up in an exponent of 5. So you know that you have to use some kind of a log to solve it, but we don't know, should we use log base 2? Should we use log base 5? And actually, you can use either. In fact, you could even use a natural log if you want. That may be what I'll do, because I know in the end I need the approximate answer, so then I wouldn't have to use the change of base. So you just take whatever log you want. You'll see that you're able to solve it. So I'm going to choose to take the natural log of both sides. So I'm going to have that the natural log of 2 to the x plus 1 is equal to the natural log of 5 to the 1 minus 2x. But please be careful. Because I chose a natural log, I have a base of e, so neither of these will cancel directly, okay? But what we could do is we can use the property of logs to bring each exponent out in front as a coefficient. And when I do this, I would have carefully put in parentheses x plus 1 times the natural log of 2 equals to 1 minus 2x times the natural log of 5. Okay, so please remember that the natural log of 2 and the natural log of 5 are just numbers. So what we have here is just a linear equation. Oh, so we're back in chapter 2. So now it's a bit of a complicated linear equation, but it's still only a linear equation that we need to solve. And the way that we solve linear equations is that we get all x's on one side, all constants on the other side, and then we isolate. In order to do this, I need to distribute these constants. So that's why I said be careful to put the parentheses. Don't forget that they're there. So when I multiply through, I would have x times the log of 2 plus 1 times the log of 2 equals 1 times the log of 5 minus 2x times the log of 5. So far I distributed, and as I stated, my goal is to get all of the x's on one side and all of the numbers on the other side. So I can see that there are 2 x's that need to be on the same side. So what I will do is I will add 2x log 5 to both sides. Okay, so when I do that, I will be able to have x times the log of 2 plus 2x times the log of 5 plus the log of 2 equal the log of 5. So I have all the x's on one side, but I also want all of the numbers without x on the other side. So I am going to get this log of 2 to the other side by subtracting it to both sides. And when I do that, I will have x times the log of 2 plus x times 2 log of 5 equals log of 5 minus log of 2. Okay, great. So I have all the x's on one side and all of the numbers on the other side. So now I need to factor this x off. So I have x times the log of 2 plus 2 times the log of 5. See that? I factored the x off. It's just like if you had 5x plus 3x equals 8x, that 8 is coming from the 5 plus 3. So that's basically what I did there. So now this is perfect because I have x all by itself. And finally, I can solve for x by dividing both sides by this number, log of 2 plus 2 log of 5, which is multiplied by x. And so I get my answer, x equals the log of 5 minus the log of 2 over the log of 2 plus 2 times the log of 5. This whole thing right here is my exact answer. I have x on one side and only numbers with no x's on the other side. And you might have been wondering why I did a natural log instead of a log base 2 or a log base 5. As I mentioned, those would also have been fine, but I need the approximate answer. And so now you see that at this point, the exact answer entered directly in my calculator. I don't need to do the change of base formula. That is why I chose these values. It's just a personal choice. So when I enter this whole thing in my calculator, carefully putting parentheses like this so that my calculator knows what I want it to compute, I get the answer, the approximate answer, 0.234. This is the approximate answer. And actually, I think we were only supposed to round to 2 decimal places, so let me get rid of the 4. In the homework, sometimes it might ask you for 2 or for 3 decimal places. So just whatever it asks, you can do. Okay, so F and G are similar. We're going to go through them in detail, but if you want to pause the video and work on it now, go ahead. And if you did work on them and you just want to know whether you got it right or not to keep watching, the approximate answer for F is 0.141, and the approximate answer for G is 20.73. Now I'm going to explain in detail how to solve each of these. So in part F, we have pi to the power 1 minus x equals e to the power 7x. Again, x appears in the exponent twice. So I could use a log base pi or a log base e. I prefer log base e. Actually, you can use whatever base you want, as I showed in part E, but I'm going to just always choose to use the natural log just for myself. Okay, so taking the natural log of both sides, to begin with, then I actually have even better situation here because the natural log of e to the 7x is just equal to 7x. And on the right, on the left-hand side, I have the log base e of pi to the 1 minus x, so that can't directly cancel, but I can use the properties of logs from section 4.5 to bring the exponent down. When I do this, I have 1 minus x times the log of pi. Again, please put parentheses around it because the entire exponent 1 minus x is multiplied to the number log pi. And this is going to just equal to 7x. Okay, great. So now that you've done something, you need to look and see what you have and what you should do. So I see that I have a linear equation now, and therefore what I should do is get all the values with x on one side and all of the numbers without x on the other side. And in order to accomplish this, first I must distribute the log of pi by multiplying it through to the quantity 1 minus x. When I do this, I will have 1 times the log of pi minus x times the log of pi equal to 7x. And as I said, I want to get all x's on one side. So I will put the x log pi on the same side with the 7x. Okay, so when I do this, I will have that the log of pi is equal to 7x plus x times the log of pi. Okay, great. Now I have all x's on one side and all numbers on the other side. So I need to factor off the x so that I can isolate it. So here I have x times 7 plus x times the log of pi. I factor. You can double check that if you multiply that x back in, you got what you started with. Okay, and finally, to get x by itself, I'm just going to divide both sides by the number 7 plus log of pi. Therefore, my answer is that x is equal to the log of pi divided by 7 plus the log of pi. This is what x is equal to exactly. And to find the approximate answer, I just plug this on my calculator, always putting a lot of parentheses so that my calculator knows what I want it to do. And then I get 0.14 for my approximate answer, rounded to 2 decimal places. Okay, so I think you will start to see a pattern when it comes to solving this type of equation in terms of the steps that you need to do. At first it seemed a little unusual, but I'm sure we can get the hang of it. So we can do one more like this, which is part G. E to the power x plus 3 equals pi to the power x. Again, I have x in the exponent, so I will take the log of both sides in an attempt to get rid of it. So the log of e to the x plus 3 equals the log of pi to the x. The log of e to the x plus 3, since we have the same base, is just equal to x plus 3. But on the right-hand side, we need to just pull the x down in front. So I just have x times the log pi. Okay, log is a function, so log of pi is the input into the log function. So that's a number. This is function evaluation, and then this is the multiplication. Okay, don't get confused. Log by itself without anything in it is not a number. Sometimes people think, oh, I can just divide by log and cancel it, but be careful, that doesn't make sense. That's completely strange. That's like having the square root of x divided by the square root equals x or something like that. No, it doesn't make sense to do that, okay? So that's just a clarification, a remark about something that I often see students getting confused about. All right, so now that we have that, we want to get all the x's on one side and all the numbers on the other side. So I'm going to subtract x to both sides of this equation, and I will have that 3 equals x log pi minus x. So I got all the x's on one side and all the numbers on the other side. Now I just need to factor the x off so that I can get it by itself. So this x is multiplied by the log of pi minus 1, because x is equal to x times 1. So the last step is to divide both sides by this number, log pi minus 1, so that we get x by itself. So x is equal to 3 over log pi minus 1. This is the exact answer. And when I put it in my calculator carefully, I get the approximate answer, 20.73. Okay, so I showed you how to solve a little bit more complicated exponential equations of this form. I'm going to pause this video and then make another video for the last page of problems, which is a different kind of exponential equation.